Welcome back. In the previous video, you learned about annuities and loan payments. But instead of financing, you can also often lease. So in this video, let's go for a ride. Let's lease a car. For example, in February 2025, Tesla was offering a 36-month lease for a base Model 3 for $249 a month for 36 months, plus a $3,000 down payment, plus an acquisition fee of $600, plus a disposition fee at the end of $400. Assume the prevailing interest rate is 4.5% per year, which is what it was about the time, or 0.375% per month. What are you paying today for the privilege of driving a new Model 3 for 3 years?
Please pause this video now, answer the question on a piece of paper, and then continue.
Okay, so we need to sum up all the present value of all the various payments. The first one is the $3,000 plus the $600 today, which have a present value of, ta-da, $3,600. More interesting one are the 36 months of payments of $249 each. So for that, we use an annuity, the normal formula, which is C times 1 over R times 1 minus 1 divided by 1 plus R to the power of the number of months. You do that and you get the number. The price is 33.617C. Okay, you use the formula, you plug it in, and you get a present value of $8,371. The disposition fee of $400 in 36 months has a present value of $350. That's just discounted by 0.375 per month, 36 months. Take the three present values, sum them up, and you get $12,321 in terms of today's dollars. For comparison, let's see whether this is really a good idea to take. The expected depreciation on a Model 3 today is about $22,000. That is the last 3 years. Let's go back. The present value of those payments was only $12,000 plus some. So that alone is much, much larger in terms of the depreciation. And the depreciation will only accelerate because electric vehicles are getting better and better every year. Their batteries become better, their various insides become better. The depreciation is not going to slow down. And also, don't make this mistake to think that only gasoline cars have this kind of depreciation. In 3 years or so, electric vehicles are even going to be more desirable. They become cheaper, they become better. At that point, also nobody will want to buy an expensive gasoline car anymore. Now, if you wanted to resell it 3 years from now for $22,000 less, you would have to discount the resale price. So the lease in this case is clearly a far superior choice to the outright purchase. Now, it is true that at the end, Tesla will nitpick you for dings and this and that and the other. And of course, you will have to live through the embarrassment of driving an Elon Musk vehicle for about 3 years. Nevertheless, this lease looks very attractive. It also looks as if Tesla is pretty desperate at this point in time to move vehicles. Now, another good question is, what would be the equivalent lease rate if there were no chunk payments, which is the $3,000 upfront, the $600 upfront, and the final disposition fee? What if it was just monthly payments and that's it? Work this out, please.
Please pause this video now, answer the question on a piece of paper, and then continue.
Okay, to work this out, we take the cost of the lease effective today, present value, which was $12,321, and we plug it into this formula. So we still have the same interest rate. We still have the same formula. Now we solve for C. What would be the every month price if there was nothing else? You work this out, it's $367 a month. This is not as fake low as the $250 a month was. And in my opinion, all leases should be forced to also quote this. It's similar to how we have normal bank loans or mortgages all being required to quote an APR. That number would be a very good number for consumer friendliness and to spur some competition. But it's not there, so you can compute it yourself. Now, this is becoming important when you have to compare different leases with different time periods. It's very often also for cars. Some leases are for 3 years, some are for 39 months, some are for 24 months. So how do we compare these leases? And we're going to do this roughly the same way. Here's an example. So a landlord gives you two choices: payments due at year start, just to make it easier, a 2-year lease at $12,000 per year, plus a one-time extra upfront payment of $8,000, or a 3-year lease at $15,000 per year. Cars, buildings, many different things have arrangements like that. So the first option costs $32,000 in total for 2 years. Go back. Was $12,000 times 2 plus the $8,000. The second option was $45,000, but it is for 3 years. So yes, it's more expensive, but of course you get the building for longer for that. Option 1 takes more money up front. Option 2 is cheaper per year. By money up front, I of course mean the $8,000. Which one of these is actually the better lease? So, work out option 1. The present value of the lease is $20,000 immediately, $12,000 plus $8,000, plus $12,000 discounted for the future. Work out what this would be equivalent to the same payment every year. That comes up to be $16,000 per year. Or work out option 2. In this case, the present value of the lease cost is $15,000 plus 15 divided by 1.2 plus $15,000 divided by 1.2 squared. That turns out to be about $38,000. Solve this for the C, that is the same payment 3 times in a row, and you get about $30,000. So option 2 seems the cheaper lease at $15,000 per year rather than $16,000 per year. But what if you need the building for exactly 2 years? What if you need the building for exactly 3 years? Well, in that case, a particular lease may be more appealing to you. What if the building 2 years down the line for the 3rd year is actually worse than the 2-year-old building? So when we do the same annual payment or the same lease payment, we're sort of making the assumption that it's all the same, whether it happens in the 1st year or in the last year. That may not necessarily be the case. So the method of what we have done is called equivalent annual calculations. Let's change gears for a moment. Let's figure out how much we have to set aside if we want to go give up corporate life and retire to some island. We're going to do retirement instruments. You can purchase a stream covering payments for as long as you live or for a fixed number of years. There's actually instruments out there. If you go to an insurance agent, they can quote you. This is a really big industry. I mean, the retirement industry is only about $3 trillion in size. That's $3 million. This is a really, really big deal. One day, you will care about this stuff too, even if you don't plan to retire on an island. So, say you want a retirement annuity that pays $100,000 per year for 15 years. If an insurer offers it for $806,070, what is the implied interest rate?
Please pause this video now, answer the question on a piece of paper, and then continue.
And for the answer, you again use the annuities formula, the present value. It's offered for $806,070. We also have the amount of payments that you're going to get, which is $100,000. We have 15 years, and now all we need to do is solve for the R. So how to solve for the R is actually somewhat complex, but you can check that the answer that I give you is correct, which is 9%. So if you plug in 9%, that equation should hold true. Now, if the prevailing interest rate is 10% per year, and you put aside $1 million to cover 18 years of expenses, how much could you draw down in equal payment chunks each year?
Please pause this video now, answer the question on a piece of paper, and then continue.
Set up the formula. $1 million is to set aside, 10% is the interest rate, 18 years, solve for X, and the answer is $121,930. Okay, now the prevailing interest rate is 10%. You want to draw $100,000 every year to cover 18 years of expenses. How much would you have to put aside?
Please pause this video now, answer the question on a piece of paper, and then continue.
Formula again. The present value is 100,000 divided by 10% times 1 minus 1 over 1.1 to the power of 18. So that number is $820,141. Now, in the real world, many times when people are trying to do this, they realize that inflation is going to erode the value of money. So they don't want to draw just $100,000 every year. They want to draw $100,000 times 1 plus G, the inflation rate typically in this case, and the problem is solved roughly the same way. And of course, you have to set aside a little bit more if you also want an inflation kicker on top of this. Let's switch gears again. We're going to go corporate again. After all, the name of this course is Corporate Finance, and I don't want you to complain that I didn't teach you what you were promised. So let's look at how most firms raise public debt financing. A bond is really a loan. It's just a different name. There's little conceptual difference between a loan, a note, a bill, and a bond. It's really all the same thing, except typically bonds have certain common features that loans could also have, but many times don't have. So, for example, most bonds are taken out by companies, large institutions, including financial ones like Fannie Mae, governments, and therefore are typically much larger than the kind of loans you would take out for yourself. Other common features. Most bonds are coupon bonds. That is, they make interim coupon payments. Most bonds are level coupon bonds. That means not only do they have regular payments, it's the same amount of coupon every time. And when it comes to corporate bonds, they are usually semi-annual level coupon bonds. That means they pay a coupon twice a year, every 6 months, always the same coupon. And many, but not all, typically have a one-time large balloon principal repayment at the end. So, other common features, often but not always, bonds are prepayable at pre-agreed terms. So if you take out a mortgage, it has to have this feature. That's actually almost required by law for ordinary mortgages. So if you've taken out a mortgage, you can go to the lender and you can say, I want to prepay my mortgage because I found a cheaper mortgage elsewhere. Now, because all mortgages are prepayable, the lenders, of course, charge a higher interest rate, taking into account that they know that if the interest rate goes down, you will want to refinance your mortgage. Nowadays, many bonds and even loans are bundled and they are sold from one lender to the next lender. It's actually somewhat rare that the same lender will hold loans, mortgages, bonds for the entire life. So if I hold your loan or if I hold your bond, I may decide to sell it to somebody else. So let's work out a semi-annual level coupon bond, which here, for example, works as follows. Take the principal, which is often quoted as 1,000 for corporate bonds, multiply it by X% for the coupon payment rate, divided by 2. This is the coupon that's paid every 6 months. So for example, an 8% semi-annual level coupon bond pays, because it's 8%, $80 every year. That's divided by 2. So it's $40 every 6 months. It doesn't really pay $80 every 12 months. It pays $40 every 6 months on the $1,000 in principal. And then at the final maturity, it pays back the final interest payment plus as one balloon payment, the amount that you have borrowed. The 8% is not an implicit interest rate on the bond. It is just a standard way to tell you about the coupon flows. So it's not even an interest rate. Again, 8% coupon. An 8% bond is just a way to describe to you $40 of payment every 6 months. For example, say we've got in September 2020 a corporate bond by American Honda Finance. It was a 1% medium-term notes due September 2025. That means it was a 5-year bond. It also had an A3 rating, which means it's pretty safe, for $750 million. What are the interest and principal payments?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, in this case, 1%, $750 million is the principal, and we're going to pay that every 6 months. So we are going to pay $3.75 million in 6 months. Well, not we, Honda. Then they're going to pay another $3.75 million in 12 months, and so on, until 60 months from today, where they're going to pay $3.75 million plus the principal. A zero bond has no interim payments. How do you earn interest on a bond that gives you no interest payments?
Please pause this video now, answer the question on a piece of paper, and then continue.
And the answer is that the interest is implicitly embodied in the lower bond price today. So you can figure out what the rate of return is going to be from now until the end. And as I told you in an earlier lecture, an interest rate is just the rate of return. Now, the IRS has special rules to tax you immediately on this interest rate. They're going to make sure that they impute a rate that you can't escape your tax obligations. So they show you no mercy.
Please pause this video now, answer the question on a piece of paper, and then continue.
Is the coupon rate of a bond equal to its interest rate?
Please pause this video now, answer the question on a piece of paper, and then continue.
No. For example, we just did one. A zero bond has a zero coupon, but of course, even zero coupon bonds offer positive interest rates, positive rates of return. What is the implied interest rate on a Walmart 3.5% semi-annual coupon bond?
Please pause this video now, answer the question on a piece of paper, and then continue.
You can't answer this. You only know the coupon rate. That only tells you the payment pattern. Depending on what the price of this bond is, you cannot figure out what the rate of return on this bond is. Now, it is conventional when a company issues a bond, they try and pick a coupon rate that's similar to the prevailing interest rate. Doesn't have to be, not always the case. However, this is absolutely not the implied interest rate, because just the following day, the price of the bond is going to change, and therefore the interest rate on that bond is going to change again. Now, I want to cover one more subject briefly that's also in the corporate realm. Remember the pro forma terminal value we used just 2 videos ago? I told you at the time that nothing lasts forever, and I also told you you shouldn't take the numbers too seriously, and that it often makes sense to shave it down a little bit too. So let's look at my claim a little bit more precisely. If your firm in the real world isn't going to last forever, say more than a few more decades, how badly are you overstating the value when you use the perpetuity? What fraction of a perpetuity's value comes from the first T years? How reasonable an approximation is a perpetuity for an annuity? If you incorrectly use the perpetuity, is this a forgivable sin? So we take the algebra. Take the difference between the present value of the perpetuity and the present value of the annuity, and the difference in these formula is the factor 1 minus 1 divided by 1 plus r to the power of t. This fraction is larger if r and t are bigger. So when r is 5%, a 20-year annuity is only 62% of the perpetuity. Oh, wow. If I use the perpetuity in this case, I'm going to have a problem. I'm going to dramatically overvalue it. The 30-year annuity is a little bit better. It's 77%. Once the interest rate is 10%, the 30-year annuity captures about 94% of the value. So at this point, really, it's almost the same thing for practical purposes, and it doesn't matter that much anymore. So the lesson of this is that with higher discount rates like 10 to 15%, a perpetuity with just a little bit of shaving, a little bit of the money away is probably good enough. Don't take eternal payment guesses too seriously. Chances are that your firm will go bankrupt anyway, far before you get to this eternal payment guess. Now, Chapter 3 also contains proof of formulas. It has a formula for a growing annuity as well. It's rarely needed. It's only beloved by sadistic finance professors on exams. Not by me, since I'm such a nice guy. That's it for this video, for Chapter 3, and for our coverage of both perpetuities and annuities. In the next chapter, we'll take a brief detour into capital budgeting again. Remember, this is the process by which you decide whether to take or not to take your project. Before we start on scenarios more exciting and realistic than our perfect certainty capital markets, constant interest rate scenario, we'll have to firm it up. See you soon. Bis bald.
Why aren't you taking a loan?
I have no interest in loans.